terms of fears, I mean, exposure to involuntary risk, psychologically, that really what grips people. We saw the SARS, now we're here conversations about avian flu. Again, statistically, is this something we should be concerned about at all?
Well, there's the possibility for a pandemic, but on the other hand, I do think people exaggerate the fear. So one way to think of it is historically, in the sense that there have been a number of other diseases that everyone thought were going to be the next pandemic, and for the most part they weren't. So that suggests right away that just because they say, oops, this might be the next pandemic, doesn't mean it is. Also with avian flu, there's this fact that it has not yet been known to be transmitted from human to human, and that makes it easier. It means at the worst we have to protect ourselves from the birds, but not this exponential growth among each other. And so those are two things. So I don't know, I'd say, you know, we should be cautious, we should have emergency plans in place, but I don't think we should worry as much as some people do.
Now, you have a whole chapter in public opinion and polling, which is a public opinion pollster is both amusing, but also, quite frankly, welcome, because we constantly get not just questions, but tremendous misunderstanding. So I'm glad you're here as an uninvolved, you have no vested interest, explaining, you know, something about polls. First, explain to the viewers what they talk about with margin of error, plus or minus 3.2.
Yeah. Right. So I mean, first of all, of course, the margin of error, well, it's like, I don't have to tell you one of the greatest pollsters in Canadian history, but for the audience, margin of error doesn't take into account things like, you know, the people who refuse to respond, and the fact that people might change their mind between now and the election, and the fact that people, you know, they're not home to answer the phone and so on. So there's a lot of issues there.
Those are the other biases that can
Right, exactly.
Unrelated to the inherent ones.
Right, unrelated to the margin of error, which is just based on the sort of the sample size, and it's again like when flipping those coins. So well, the way I like to think of it is, suppose you flipped a coin and you didn't know the probability of heads was 50%, and you're trying to sample that like you would for a poll. Well, if you flip it a few times, you won't be close to 50% at all. The more times you flip it, as we discussed, the closer you'll be to 50%. But you still say, if you flip it 1,000 times, well, you'll probably be pretty close. And it turns out that, again, you know, if you do it 20 times in a row, about 19 of those times you'll be within about 3.1%, right. And that's what we call the margin of error. But it's still possible that one time in 20 you'll be way off. So in the case of polling, you know, you could be really unlucky, and you happen to only phone people who are going to vote for the Liberals, and you just got an answer that's way off. So.
But we never see a poll published saying, this is 1 out of 20. This is an outlier. This one stinks.
That's right.
Yet what you're telling us is that we should be cautious.
Well, that's right. I mean, any one poll does have that risk, and that's why I think, you know, that's why we have more than one poll, right? Why there's many polls published, and people are always comparing them and saying, oh, this poll seemed to overestimate the Liberal support, and this one seemed to underestimate it, and so
on. Now, the question of whether everything is random. You end the book on a very interesting note, that some things may seem more random than they are. Introduce our viewers to chaos theory and how this fits into this whole business.
Yeah, so one way to think of it is if you change things just the tiniest amount that you couldn't even perceive, that could be enough to change the outcome. So, for example, with weather, well, there's this old story about the butterfly flaps its wings in Asia, and that suddenly makes a tornado appear in Texas a few days later. Now, actually, people have debated whether that's actually an exaggeration, but the principle involved that says that just slight changes in, say, you know, the air molecules and the water molecules mixing around, well, it could be a small change, but then that changes something else, and then that pushes this cloud a little further this way, and gradually the amount of air is built up, and things become more and more different. So that's the idea of chaos theory, and it says that if we knew exactly what was going on, there wouldn't be any randomness, but if we have the tiniest amount of uncertainty, whether it's in the molecules in the cloud or whether it's my thumb when I flip a coin, that tiny bit of uncertainty is enough to lead to lots of uncertainty or randomness in the end.
Life is full of uncertainties. Now, you give us some insights on how to balance, find some balance in very simple things, you know. Should I'm getting married on June 24th, should I have it indoors or outdoors? You know, I kind of like this woman here. Should I call her up for a date? How does random probability theory help us with those kind of day-to-day decisions?
Yeah, so in that case, I would say there's sort of 2 steps to thinking about it. And the first is the probabilities itself. So maybe you say, well, based on historic data, let's say there's about 1 chance in 4 that it's going to rain on Saturday. You know? So that you can say based on maybe historic data, or whether it's asking someone out on a date, and well, there's maybe a 10% chance they'll say yes based on what little I know about them and myself and their tastes and so on. So that's the first step. But then to really make use of that, you also have to use what we call a utility function, and that's just a numerical rating of how you feel about the various outcomes. So you could say, you know, if it rains on my picnic, that'll be a disaster. That's a minus 100, you know, whereas if we have a nice outdoor picnic in the sun, well, that's pretty good. That's a plus 50. And then you sort of balance it out. You say, well, what about that 25% chance of the minus 100 when it rains compared to the 75% chance of a plus 50, and you're always kind of balancing those things out.
And you can actually do the math.
You can actually do.
On balance, the pleasure I would get in those 3 out of 4 days where it was sunny is probably greater than the misery I would have if the one day it did rain.
Exactly. You can balance it out. So in other words, it's hard maybe to assign those numerical values. That's where your judgment comes in. But once you do, then you can make the decision in a straightforward way.
Jeffrey Rosenthal, I want to thank you very much for joining me. It's been a real pleasure.
Thank you. For me too.